Hello, and welcome to my talk about progressive delivery in Kubernetes with Jenkins X. My name is Carlos Sanchez, and I work at CloudBees. I'm a principal engineer, software engineer there. And I'm also the author of a bunch of open source projects and collaborating with different foundations like the Apache Foundation. And I started the plugin for Kubernetes on Jenkins to have Kubernetes agents on Jenkins. And so if you're using Jenkins and Kubernetes, that's probably you're using that plugin. So let me start doing a quick intro on Jenkins X. So Jenkins X includes a bunch of different tools. It uses Docker for all the container images, building the Docker images, and so, as you probably are aware of. It includes some development utilities that are really cool. So like Draft and Scaffold. Draft is built by Microsoft. Scaffold was created by Google. And Draft allows you to import and to create all these Docker images, Helm charts from your projects by detecting the code that you have in your project and deciding, what type of programming language it is and creating all this structure, Docker images and Helm charts. Scaffold is used to build these Docker images and create from those Docker images, create the Helm charts and publish this to the internal Docker registry that Jenkins X includes. Helm is the tool used for deploying applications, and I'm going to go through that in detail for these demos. And it uses Nexus for artifact caching on the internal repository, Nexus. Chart Museum to store the Helm charts that you build or your applications. Knative build for building in the serverless world. So the demo I'm going to run is with Jenkins serverless. So it uses Knative build to create these containers. And Knative build is the previous version of what is called now Tecton pipelines. That's something that is right now coming as a new project in Jenkins X. But Knative build allows you to create containers on demand. So basically, you can receive your GitHub webhooks, create containers to do your builds, your Jenkins builds, and then those containers disappear at the end of the build. So you have some idea of serverless. You only pay for the number of builds you are running concurrently at the same time. And if you are not running builds, you don't pay anything. And it can scale to a great number of simultaneous builds. And this logo, like the last logo here, is Prow. It's a project that comes from the Kubernetes ecosystem. So it's a chatbot that allows you to interact with Jenkins X through GitHub pull request. And I'll show you this in just 1 second. So progressive delivery, what it is, it's kind of a new name that it's becoming more and more used. So the definition I have here is like progressive delivery is the next step after continuous delivery, where these new versions are deployed to a subset of users and are evaluated in terms of correctness and performance before rolling them to the totality of users and roll back if not matching some metrics. So this is something that Google, Facebook, Netflix, all these really new companies or companies doing these new ways of development are using. So Facebook, for instance, every new version gets deployed first and available only for the internal employees. Sometimes it's deployed to 1% of users or some number like that. And then it's continuously checked to see if there's an increased rate of errors or everything is going smoothly. And if these errors happen, then you detect this in production and you roll it back instead of rolling it forward to more users. So it's a very interesting way of checking that your new versions are working in production. So there's always some things that you cannot test in staging environments, in test environments. So progressive delivery, it encompasses all these techniques that allow you to gradually roll out a new version, check that it's correct, and if it's not, then be able to roll it back immediately. So it includes things like blue-green deployments, Canary deployments, and everything that in between that allows you to do this progressive rollout of new versions. Now, continuous delivery, it's inherently hard. But progressive delivery is not something that you need to master continuous delivery before to make use of progressive delivery. Actually, progressive delivery really helps you adopt continuous delivery. So instead of doing a continuous delivery where every commit goes to production and deployed to every user, progressive delivery allows you to roll that out, check it out in a small percentage of users, could be even internal users, employees, something like that, and roll it progressively and to the rest of the users only if those first set of users are happy with it. So it makes it really more safe. Well, it makes it safer to adopt continuous delivery. So that's, I guess, my main message for you today. So with Jenkins X, we have, or we are working on enabling progressive delivery and specifically Canary deployments. And for that, we use several tools. But let me show you first a demo. So I have this application here, it's Croc Hunter, and I have it in GitHub, and I have it deployed to my staging environment exactly like you would do with any Jenkins X application. I have the release 137 here and this commit ID. And it's this great game that basically consists on killing crocodiles with lasers. So I could be playing this all day, but let me show you what can we do with this application. We have the same version deployed into production, and it's the same version, 137, same commit ID. So a new requirement comes in. Let's make it let's make it a little bit more animal friendly, and let's not kill crocodiles because it doesn't look that great. So we're gonna edit the file and make a change to the application. I'm gonna do this here directly on GitHub. Okay, so here I'm gonna make this small change. I'm gonna say no lasers, and I'm gonna create a new branch. No lasers. So this is basically what you would do with Jenkins X without any progressive delivery options. So I get my Jenkins X, this is using Proud, the bot that I mentioned used by Kubernetes itself, and it's commenting on my issues. You can interact with the bot. You can say meow, and the bot will answer with cat pictures. So other than that, you can do more useful stuff, and we'll see in a second. I see the build is pending. this is this pull request has triggered a build on my Jenkins X environment. And if we go here to my logs, I can see that the Jenkins pipeline is running. It's building the Docker image. It's building the chat repository. It built the Go application before, so everything is happening that right there. And while this is running, which is gonna take just a little bit of time, I can show you how this is what's running on the behind the scenes. So this is running on a cluster on Google container Kubernetes engine. Right now I have 2 nodes only in this cluster, but I have auto-scaling enabled. So if I have more builds, more machines are going to join the cluster. If I have less builds, the cluster will downscale. So I'm only paying more or less for what I'm using right now. Let's take a look at this. So this finished already, the build of my pull request. And if I come here, I can see the normal Jenkins X comment saying that my application pull request has been deployed to my pull request environment, preview environment. I can see that this is the snapshot build from a different commit. And if I play it, I can see my changes. So no longer killing crocodiles with lasers, but just throwing fish to the crocodiles. So I'm happy with this change, and I want to deploy this to my staging environment. I'm going to merge this into master, so I just tell approve to my bot, and my bot it's going to complete this check over here. It's going to approve the pull request and merge it into master. And if you are familiar with Jenkins X, you know that this will automatically deploy it into my staging environment. So far, the normal Jenkins X flow, things, pull requests are getting deployed into their own preview environments. Master is deployed into staging environments. And production is in a different environment. So in a second, this is going to be merged into master and built from master. While that happens, I'm going to show you more things that happen behind the scenes. So I can see in a stack driver logging, because this is all happening in containers in my Yiki cluster, I can see those logs from a stack driver, so I don't need to use the command line or anything like that. I have them here. I could also use the stack driver API to access those. And let's take a look if this is building. There it is. This is starting, and this is going to be the master branch build in a sec. Okay, so let's open a new window. So I can get the applications that are running on my Jenkins X cluster applications. And I see Croc Hunter Jenkins X is still 137 in both places. In a second, this is going to change to 138. And when that happens, what I'm going to do is to promote that new version into production. So let's talk about that. What's going to happen when I promote it to production is that it's going to do a Canary deployment. So how do I have set up Jenkins X to do this? So these Jenkins X add-ons are the ones that are used to do Canary deployments. So we have Istio, And we have Prometheus for Istio for service mesh, Prometheus for metrics gathering, and Flagger, which is a project that allows you to do Canary deployments on Kubernetes very easily. So you can install them in your Jenkins X cluster with JX create add-on, and this will configure your Jenkins X production environment to do Canary deployments. Istio allows you to do a bunch of different things, service mesh, so you can secure connections between different services, you can control the flow of requests through all these services, and you can monitor the services also, because Istio basically proxies every request and gathers metrics on that. So for Canary deployments, there's some things that we are interested on. One is because Istio proxies all the requests to our services and gathers metrics, we can get those metrics from Prometheus, and we can see if the requests to our service, to our Canary service, are being successful, and how long do the requests take, and we can examine these metrics and act based on that. And the other thing is that we can use the service mesh to direct a percentage of traffic to the new Canary service. So we can say, we can implement Canaries with Istio saying, send 10% of the traffic to the new version, and then it's gonna load balance based on the rules we set. Flagger automates the promotion of these Canary deployments. So it uses Istio to increase every minute by default, that this all can be configured. So Flagger was going to tell Istio, send 10% to the new application, send 20%, send 30, send 40, send 50, and then send all the traffic to the new version. And while it's doing that, it's going to look for the Prometheus metrics and figure out if the new Canary deployment is successful or not. So it's going to look at requests that are erroring, like 500 errors, and it's also going to look at the response times by default. And I'll show you how to configure that. So, one thing we have to do is, because we want to use Istio to do all the traffic shifting, we want to use the Istio ingress gateway instead of the normal Jenkins X ingress controller. So you can get the IP of this service once you have installed Istio in the cluster. You can get this with this command. This is going to give you an IP, and then you can point your wildcard domain to it, and then refer to your domains that way. So this is the entry point using Istio. That's where all these Istio rules are gonna be happening. The other thing you need to do is to configure your application using a new Kubernetes CRD called a Canary. And you can create this Canary object. And we are doing this on Helm charts. Let me show you here better in GitHub. I'm gonna go to my charts, Croc Hunter, templates, Canary. I'm saying if we are releasing to the production namespace and this file, the values file has Canary enabled, create this Canary CRD. In this Canary CRD, we are defining what deployment we are going to Canary, different options like port, gateways. This is all using defaults and the values coming from the values.yaml. And different configuration using Helms, like how often to do the Canary analysis. By default, it's 1 minute. How many times you want the metrics to fail before doing a rollback, and how much percentage of the traffic you want to route to the Canary, and so on. And This is just a template. If we go and look at the values file that you can add to your application, these are all the values that were there before enabling Canaries. But for Canaries, I'm saying enable Canaries. And if you get requests for these hosts, send them to the Istio. Make Istio send them to the right deployment. I'm using the Jenkins X gateway that is created when the application when the add-on is installed on JX. I'm using every 1 minute check for the Canaries. If three times the Canary checks fail, then do the rollback and go from 10% to 50%, doing 10% increases on the traffic routing. And there's two metrics that I'm gonna check to make sure, or to decide if my Canary rollout is successful. The request, I want 99% of the requests to be successful, and the duration of the request, I want them to be under 500 seconds, I think it is. Oh, milliseconds, sorry. And these are the two metrics I can check. And I can add any metrics I want and I have in Prometheus. So I could also modify my application to add specific metrics that I want. In this case, I'm just using the ones that Istio is sending, so I didn't have to touch my application at all to enable Canary. It's all coming from, the metrics are coming from Istio, and this is all happening like more at the infra layer and not on the application level. But you could send your own metrics if you wanted, like, I don't know, like number of shopping cart items or something like that validates that your application is working. So let's go and see. My staging should be updated to 138. There it is. So that's my new version. And my production is still on 137. So now I want to promote to production, and I want to do Canary promotion. I just have to use the normal JX command, which is JX promote. And I want to promote Croc Hunter Jenkins X. And I want to promote the version 00138. And I wanted to promote it to production. So this is going to do, it's going to submit a pull request to my Jenkins X production environment, exactly as it would do without progressive delivery, without Canaries. So it has created this pull request. And this is going to get built, and my production environment is going to be changed in Kubernetes. So it has updated 137 to 138, and this is going through the build. What's going to happen, and let me show it here. When this gets deployed to production, to the production namespace, Flagger is going to detect it and act on it. So this I already showed. I have promoted Croc Hunter to whatever version I want, to the production environment, and this is going to do the Canary deployments. So what Flagger is doing, and let me see, I need to generate some traffic to make sure that I'm getting metrics. So I'm gonna run here somewhere else. I have these instructions on the application README, so this is just creating some traffic. And is printing the status and the version that is the application is responding with. So far it's 137, and soon it's going to change. Let me see if this has changed. Okay. If something is happening already. Not yet. There should be a build happening. Yes, there's the build happening, and soon it's going to be deployed to production. What's going to happen, so the requests are going to come through Istio to the Istio virtual service, and this is all created by Flagger. So Flagger talks to the Kubernetes API and talks to Prometheus to get the metrics and creates the virtual service on Istio. And then Istio is basically taking over and sending traffic to the primary and to the Canary based on what configuration Flagger is setting. So it's going to start with 100% goes to the primary, nothing goes to the Canary, and then 10% every minute increase. And you can also have Slack notifications from Flagger when this is happening. So the steps are going to be, in my case, it's going to be 10% every minute, but it's going to, Flagger is going to send traffic to the previous version, the new version, and it's going to increase it until it gets to a point where all the traffic is going to the version, to the new version, and then the old version is scaled down. And you can combine this with the horizontal pod autoscaler. So if you have a lot of traffic, this you can make Kubernetes automatically scale the number of pods that are serving both versions. Let's see if this has started already. Okay, there it is. I'm going to, okay, this is not showing everything. Wait. Oops, there it is. Let me make this. Try to get this. Okay. Here. This is the hardest part of the demo. Okay, here it is. So I have some messages from Flagger in my logs. So it has detected a new revision. So it's scaling up the new service, the Canary. We're starting the Canary analysis. And here, advancing JX production. Let me see if this is showing everything or not yet. Not yet, there it is. Okay. Oh. All right. Oops, there. Okay. It's better. So Canary weight is 10%. Canary weight is 20%. So every minute it's going 10% more. If I look at my curl request, I can see that some of them are returning 138. So if we look at the numbers, this should be 20% of the request and returning 138. And this is going to take 5 minutes to roll out completely. And the other thing that Flagger includes is a Grafana dashboard, and I'll show you live. This is running on the cluster, and I can, okay, let's see. Namespace, no. This is not the namespace I'm looking for. Do I have the right thing? Ah, okay, maybe I'm running in the wrong. Yes. Okay, let's refresh it. Oops. Okay, So I have, I want the primary and I want this. There it is, last 5 minutes, refresh every 5 seconds. And this should be it. This is getting requests, okay. So here I can see on the left, my primary, which is the old version, and my Canary, which is the new version. I can see the request volume and the success rate for both of them. I can see the request duration for both of them, CPU usage, memory usage, and network I/O, and request by source and response code and outgoing request. So this is a Grafana dashboard that you can look at it, or you can edit to fit your needs if you want. So I can see that all my requests are happening here. But let's do something while this is running. If I do it quickly enough. Oh, it already finished. So it got from, is it here? Yeah, it got to 50%, and then it decided to, okay, the rollout has been successful, and it has automatically copy the Canary to be the main version. So this is it, promotion completed, and then it's scaling down the Canary. If any error happened on the meantime, then you could see here the request failing, and you would get automatic rollback. It would basically scale down the Canary deployment and scale back up the primary deployment, which is the old version. And okay, let me go back here. This is the other thing. Well, let me show you that production now is 00138, and all my production requests are returning 10138. Here, oops, here, there. So all my requests are now going to the new version, and it's the 138.1. So no matter how many times I refresh, I'm gonna get 138. It also, Flagging also includes Slack integration, so you would get these messages when a new rollout is happening. This is the URL where you can see the application. The two only things that I had to modify are the Canary CRD, adding it, and the Canary section to the values.yaml, this section here, where I define what are my requirements for the Canary deployments. And this is basically it. I mean, it will automatically do the rollouts if you get 500 errors, or if you get increased response times over the limit you set. It's going to do an automatic rollback, and you don't have to do anything. You don't have to even modify your application, because this is all happening with the magic of Istio, Prometheus, and Flagger running on Jenkins X. And that's everything I have. And if you have questions, feel free to ask them here, and or ping me on Twitter. That's Sanchez. Thank you for joining me today.